Good morning, everyone. First, I will introduce myself and my colleague will introduce himself. So my name is Lorna Quandt. I'm an associate professor at Gallaudet University in Washington, DC. If you don't know, Gallaudet University is the world's premier university serving deaf and hard of hearing students. And it is a fully bilingual university. We use American Sign Language for all in-person communications and English for written communication. So that's me, and my colleague Shahinor will introduce himself.
Hi, good morning, everyone. It's almost noon, but looks like it's 8 a.m. in the morning. I'm Dr. Shahinur Alam, working as a postdoctoral researcher in Action and Brain Lab and Motion Lab at Gallaudet University, and I do research on artificial intelligence and virtual reality.
Great. So today we're going to talk to you about a key project that we've been working on now for about 5 years. And this project is called ASL Champ. So we have been fortunate to receive funding from the National Science Foundation to support this work under a mechanism encouraging research in emerging technology for learning. So that is what is sort of driving this work. Okay, so some background motivating the purpose and really the goal of this work is that we know that more than 90% of deaf children are born to hearing parents, and the vast majority of those parents will not know any sign language at the time of their child's birth. However, we also know from decades of research that exposure to American Sign Language early in a child's life gives them a great chance of enhancing literacy outcomes, academic outcomes, and improving their later quality of life. So this is sort of something we keep in the back of our mind that motivates the big picture driving this research. What we want to do is harness the power of emerging technology to provide new ways to learn American Sign Language. So why I described these deaf babies is not because we're designing XR for babies, but rather we have a societal goal, which is to get more people signing, more people comfortable with ASL for the benefit of those deaf babies, deaf families, deaf children, and deaf adults. If we want these hypothetical new parents to learn American Sign Language, to start picking up some signs, here I'm giving you sort of an anecdote. We could imagine other uses for our product that you're going to see, but this is one anecdote that really helps us work towards our mission. Waiting for my slides. They just disappeared. Got it. Okay. I will just talk. So if we imagine that we want these hearing parents to be able to pick up ASL, there are a few different ways that they might do so. We, on our research team, 100% agree and acknowledge that the best way for anyone to learn a new language is to go to a class, ideally in person, and learn from a skilled deaf teacher. That's best case scenario. However, that's not always an option. It's not always something that people are able to afford or drive to or find in their local community. Especially if you think about our little anecdote with new parents who have a baby in the house. It's a lot to imagine that they might be signing up for a class in person on a schedule and paying money and doing homework. So although we know that an in-person class might be the best option, what other ways might someone learn American Sign Language? Typically, options exist like looking in books, but books are really not great for learning sign language. Movement, depth, 3 dimensions, there's a lot lacking in books. You might use an app, which is helpful. And there are some great apps that my colleagues have created. You might use a YouTube website. There's tutorials, there's free material. However, apps and YouTube both lack something that is critical for learning, and that is feedback. So if you are learning your first ever ASL 101 signs, you're learning a sign by watching it. You try and produce that sign. If there's no one to tell you if that's right or wrong, or you're understandable, or you need to move that hand in this way or that way, without feedback, your learning opportunities are really limited. What if we could build a tool in virtual reality to take advantage of the three-dimensional depths potential in VR, that can represent American Sign Language in its full three-dimensional space and provide real-time feedback about people's signing? So that's what we're trying to do. And as you all know, the technology is changing every few months. There are new options. Right now, we're designing for immersive virtual reality on the Oculus Quest 3. But we could imagine that this might also be applicable to augmented reality or other tools that are developed in the next few years or the next 10 years. What our game looks like, ASL Champ, is the user of the VR device is basically the student in a simple ASL 101 learning interaction. So we are very fortunate that we have within our lab at Gallaudet the capacity to build really high quality signing avatars. So you'll see more in a moment from Shahinor about how we make these signing avatars. But essentially you, the user, are standing a few feet away from a signing avatar who is your teacher, and she teaches you individual words based on the environment around you. So you'll see in our example, we have created a coffee shop environment where people can learn introductory signs, coffee, tea, milk, cookie, by sort of interacting back and forth with this teacher. So we have the teacher who's this animated avatar, and importantly, she signs ASL recorded from a deaf signer. So her signing looks pretty natural, it looks high quality, it feels pretty realistic when you interact with her. And you have the student who is yourself, the user. And if you come to our demo later today, you can try the game and be the student yourself. And underneath the hood, we have the deep learning algorithm, which recognizes the user's signs and provides feedback about whether the user is correct or incorrect. And that feedback comes from the teacher, the signing avatar, in the form of her saying, yeah, that was great, we'll go to the next one, or not so much, try again. So we have integrated 3 elements into the game to provide a simple back and forth. And of course, this work comes with disclaimers. This is research work. We are at a proof of concept prototype stage. We are not at a fully fledged marketable game yet. We also are currently doing individual signs. So in the future, the same technology could be used to teach sentences, phrases, and conversations, but right now we're at the one word stage. Okay, I'm gonna give this over to Shahinor, who's gonna tell you more about what's happening under the hood to make ASL Champ possible. And you'll see some videos of what it looks like.
Thank you. So a couple of things we are already clear that we want something to build a real student-teacher interactive environment. And another thing is the feedback system, whether the user is producing the correct sign or not. So as Jasmine already described before, that the avatar looks like a shape and just moves like the robots. So this is the one of the important challenge in our game as well. So this kind of development requires like 3D designer, animator, some tech guy, and everything. So luckily, we have all of these. We have a 3D designer, we have animator, we have mocap engineer, and also deep learning guy that ended up with an awesome looking 3D avatar and the recognition system. So what we have done, first, we have designed a 3D avatar in Autodesk Maya. And at the same time, our mocap engineer just recorded a 3D movement of a fluent native signer, and that was blended to Unreal Engine, and we have generated a 3D real-looking human-like 3D avatar. And at the same time, in the technical section, we have created a deep learning model so that when the user signs a sign in a virtual environment, our system can recognize whether the sign is correct or not. And also, we have created data set for this, all in-house, as Dr. Lorna already said. The Gallaudet University is the world's only deaf university, so we have a huge source of native signer. So we have collected data sets, and that data set are used to train our deep learning model. And the deep learning model is the main building block of our feedback system. We have planned creating multiple levels and started with a coffee shop environment. Here you can see real coffee shop environment. In the right side, you can see a user wearing a VR headset, and at the left side is the real coffee shop environment. And when user play the game, here you see that a beautiful looking a barista is welcoming him or her to teach some sign. I'm not sure how to play the video. Can we play the video? Oh, thank you. So this is our coffee shop environment. We will have a detailed demo in future. I mean, in next couple of slides. So I already mentioned that our main goal is to teach sign language as accurate as possible. So that's why we have invited a fluent signer. Here you can see the model is a deaf fluent signer. And we have used a Beacon system equipped with 18 cameras that and 73 markers on signer's body that just recognize the model's movement and motions. That has been captured and blended to the Unreal Engine, and that's how we can say that the avatar is as real as natural as human. As we are working on the deep learning model, we need to collect some data to train our model. So we have designed a different user interface to collect data. So here you can see a user is signing in the real environment, and the right side is the data collection user interface. So we have collected total 2,700 ASL sign and from the 15 fluent signer. So the UI is just self-explanatory. We don't need much intervention on this process. They can do it by themselves. And also, there is a capability that they can verify whether their sign is correct or not. The sign recognition process is the basic building block of our feedback system. We have used two different methods. First, in our initial approach, we used a third-party plugin called MyVRY, and now we switched to our custom-made deep learning model. So this is the model diagram or model structure of our deep learning model. I'm just gonna skip that one because of time limitation, but I'm always open to discuss here if you are interested. This is our result, qualitative analysis. Here you can see the user is signing a coffee, and the avatar is nodding down her head and said, yes, this is the correct sign. And she is showing another sign like tea and asking to the user, what is this sign? And user is signing tea, and avatar saying, yes, this is the correct sign. So we have 9 different signs in this environment, and the video is too long and it will go as same as this. So I'm skipping that one too. Yeah, here is our quantitative result, and we found almost 90% training accuracy and 86% test accuracy. And also we have generated a confusion matrix to verify whether which sign is exactly doing better and which is wrong. Here you can see the highest accuracy found for coffee, tea, milk, muffin, and cookie, but we have the lowest accuracy for cup.
Okay, thank you, Shahinur. So you can see a little bit about under the hood, what makes the system work. We have that sign recognition system operating under the hood, powering the teacher's feedback to the student to allow them, hopefully, to refine their signing and understand what they should be what they're doing right and what they're doing wrong. We wanted to learn a little bit more about how people reacted and experienced this game at the prototype stage that we're at now. So we brought in participants. We had 12 hearing non-signers because this is our target group, people who don't already know any sign language. And we asked which elements of the game will impact their experiences the most. So essentially we brought them in, we had them play a couple levels of the game, and we recorded their entire experience while they narrated out loud. So as you can see from the GIF, we're getting their sort of real-time reactions. In the GIF, there's a person with the VR goggles on going like, it's so real. So we got to capture people's authentic responses to being in the virtual reality environment. I'll go through this part a little bit briefly to allow us to move closer to our scheduled time. We're happy to chat about it more during the demo this afternoon. So we recorded the participants' experiences and we ran a sentiment analysis on what they said during their experiences. So they were talking out loud. We asked them to talk out loud the whole time, even if it felt a little unnatural. We wanted them to narrate exactly what was going on. So like, oh, she's asking me to grab the milk. Maybe I think she's getting frustrated with me. Whatever they thought was happening, we asked them to say it out loud. Then we transcribed it, cleaned it up, and ran an analysis to see their own quantitative reactions to the game compared to the sentiments that they expressed during the use of the game. That's the sentiment analysis, allowing us to see which factors of the game were most impactful for determining their experiences, their sort of perceptions of the game. So our takeaways from this, and the data support this with these negative correlations that we have shown here. So one important thing that really helped support the centrality of the sign recognition software for us is that users understood and felt like better sign recognition accuracy. So the better that part performed, it made them feel more positive about the game. So when they felt like the sign recognition was working well, they liked the game more, they felt happier, they were expressing more positive feelings. But when that sign recognition was not seeming to work well for them, it negatively impacted their experiences. We also found that users who find the game more intuitive express less negative sentiment, so not surprising, but users like it to be more intuitive and self-explanatory. I'll close that for now. Our next steps for development are to expand our ASL vocabulary. So we're continuing to add more lessons, more environments, more signs, and more content. Similarly, we're training the sign recognition system and developing that deep learning model to continue to improve the accuracy of sign recognition. Overall, improving the game experience, making it more intuitive, more self-explanatory, and more accessible. And finally, we're also seeking industry partnerships, so looking for ways to scale up or take the next step of this work after we have continued to complete a prototype. And of course, this work does not happen alone. Shahinur and I have multiple great teams working to make this all happen. And everyone on this screen has their own part to play in this work. Questions and feedback can be given directly to us. Hopefully we'll see some of you at the demo this afternoon, where as long as the tech gods are cooperating, everyone can try out the game for themselves. And you can also find us via email or our websites. Thank you so much.